Hey guys, Math Unlocked, and today we'll be learning about arithmetic sequences and series. I'll explain to you what these are in the next slide. I have a couple example problems for you, then I have some practice problems for you guys to try, and then that's the end of the video. So let's get right into it. Alright, looking here first, we have two sets of numbers. We got 1, 2, 3, 4, 5, and then we have 1 plus 2 plus 3 plus 4 plus 5. Now, one of these is a series and one of these is a sequence. This one right here on the top is your sequence. This one on the bottom is your series. And what a series is pretty much just adding up all the numbers in your sequence. So let's find out the sum for the first 10 terms of this sequence. So we got a couple formulas right here. And then this one, but we're just going to ignore this one for now. That one will come into play later. Alright, so looking at these, we do not know what the 10th term is. And we're going to use these two formulas first. So in this formula, you need a of n. And a of n, that's just your last one. Alright, so, and we also have a of 1. And you guys probably don't know what those are, but I'll explain that to you right here. So in your series, you have all these terms. You got this first one, you got this second one, third one, fourth one, and your fifth one. Well, your first one is going to be a sub 1. Then your second one is a sub 2. Then your third one is a sub 3. That's a terrible 3, guys. A sub 3, there we go. Now a sub 4. And it just keeps going on and on and on until you get to your 10th term. And your 10th term is going to be a sub 10. Alright, now what a sub n means, the n means the number of terms. So n is equal to 10. Alright, and that's important because we have that right there. Alright, so now let's look at this. We have our a sub 1, so we'll just write that off to the side right here, and that's equal to 1, a sub 1 right here. Now a sub 10, we do not know what a sub 10 is right now, but you guys probably could just easily figure it out. So we need to figure that out, and we also need to figure out what n is. Now n is just the number of terms, and it says find the sum for the first 10 terms up there, so we know that n is equal to 10. Right, now to find a sub 10, we need to plug it into this formula. And you can replace this n right here with the 10, so we get a sub 10 is equal to a sub 1, which is 1, plus the quantity n minus 1, and we know n is 10, so it's going to be 9, because 10 minus 1 is 9, and then d. Now what d is, that's the common differential between each number. So the common differential in this one, well, to get from 1 to 2, you have to add 1. To get from 2 to 3, add another 1. From 3 to 4, you add 1 more. So now we know that that is equal to 1. So multiply that all by 1. Alright, so now we get 1 plus 9 times 1. Well, 9 times 1 is 9. 9 plus 1 is equal to 10. So we know a sub 10 is equal to 10. Alright, now that we got that, we can put that over there with all of our other variables. Okay, so a sub, oh, we already have it written. What am I doing? So that is equal to 10. Alright, now we can plug everything we have into this formula. So a sub s, and that just means finding the sum of this sequence right here, and that's equal to n, so n is 10, so 10 times the quantity a sub 1 right here, so that's equal to 1, plus a sub n, which a sub n we rewrite that as a sub 10, that's our last term, and that's equal to 10, so 10, and that's all over 2. Now we just simplify and solve, so we get 10 times 11, which is equal to 110 over 2, so 110 over 2 and that's equal to 55. So a sub s is equal to 55. Alright, and that's our answer for this problem. Alright, let's move on to the next. Alright, so for this problem we have 1, 5, 9, 13, and 17. That's our sequence. Alright there. And our series is 1 plus 5 plus 9 plus 13 plus 17. Alright, so now for this problem we're going to use this third one right there. So we need to figure out what n is, a sub 1 is, and d. And that's all we need for this one. So this one's actually going to take less time than using these two equations. And it's going to be a little bit easier even though the equation looks a little bit more complicated. Alright, so let's start identifying our variables. So first variable, n. We know that we need to find the sum for the first 15 terms up there. So n is equal to 15. Alright, so now a sub 1. Well, a sub 1, that's equal to 1. Terrible circle, but we'll live with it. So, and then we need to find d. So d, we get 1 to 5 to 9 to 13 to 17. And how do we do that? Well, to get from 1 to 5, we need to add 4. To get from 5 to 9, we need to add 4. So it must be 4. Alright, so now we got everything we need to plug into our equation. So let's do some plugging and chugging. And we get a sub s is equal to n, so 15, times the quantity of 2 times a sub 1, which is 1. So 2 times 1 is equal to 2, so I'm not going to bother with writing it, plus n minus 1, so n minus 1, 14. Alright, so d is 4, so multiply that by 4. Alright, and that is all over 2. Alright, I'm going to clean some stuff up for you guys. Alright, now I've cleaned the board up, let's clean this problem up. So we get 14 times 4 plus 2. So 14 times 4, rewriting this, we get, that's equal to 56. So 56 then plus 2 is equal to 58. And we have to multiply 58 by 15. So we get 58 times 15 is equal to 870. Equals 870 over 2. So 870 divided by 2 is equal to 435. So a sub s is equal to 435. Now, if you guys want to add up all these terms from the first term to the 15th term, you can be my guest. But doing it the quick way, we get 435, and it's going to be the same exact answer as adding it up by hand. Just a lot quicker. Alright, so let's move on to the next problem. Alright, here we go. Second to last problem, we have our sequence of 1, 3, 5, 7, 9, and a series of 1 plus 3 plus 5 plus 7 plus 9. Alright, and we need to find the sum for the first 10 terms, so let's use this third one over here, and so let's start labeling. Alright, so we need n. N is equal to 10. So write that down right there. Now we need a1. So our first term is equal to 1. Alright, so now we need the common difference. And that's equal to, well, how do we get from 1 to 3, then 3 to 5, then 7, then 5 to 7, then 7 to 9? Well, we know we have to add 2. So the common difference is 2. Alright, so now we can start plugging. So the sum of this series is equal to n, so 10, times 2, times a1, which is 1, so we don't have to write that, and then plus n minus 1, the quantity, so 10 minus 1 is equal to 9. Alright, put that right there, times d, common difference, which is 2. And all that is over 2. Alright, so now let's clean this up a little bit. 9 times 2 is 18. 18 plus 2 is equal to 20. So there we go. So 20 times 10. It's 10 out front right here. Over 2. Alright, so 20 times 10, that is equal to 200. And 200 over 2, and that is equal to 100. So we can rewrite it as A of S is equal to 100. Alright, so that's pretty easy. Now let's get on to a little bit different of a notation. Alright, so you see this weird symbol right there, and you have no idea what it is. Well, that's called capital sigma. It pretty much just means the sum of. So, the sum of some sequence, so this is the sequence right there. That's the formula for it. So, and then from your first term is going to be 1, and you're going to go for 5 terms. Alright, so let me show you something. So you have 1, then we'll have 1.5, then we'll have 2. Alright, so now each of these has a number. First, second, third. And this number is equal to n. So if n is equal to 1, well, we look here and we know that it's 1. Well, if n is equal to 2, we look here and that's right there. So it's equal to 1.5. So then 3 is equal to 2. So when you have n plus 0.5, you're taking the previous number and you're adding 0.5 to it. So if your previous number was 1, then you add 0.5. And we get to 1.5. So then our previous number was 1.5. You add 0.5 and you get 2. So then you go from 1.5 to 2. You see how that works? Alright, so now let's solve this puppy. Alright, so you start at 1. So we know that a sub 1 is equal to 1. Alright, so now for our second thing we need n. So n right here, that's right there, as you can see from this formula right down there. And so n is equal to 5. So n is equal to 5. Alright, so now we need our common difference. And where do you get your common difference? Well, your common difference is right there. Alright, because we have to add 5 to each previous number. So 0.5. I don't know if I said 0.5 previously, but I meant to. So 0.5 is our common difference. So d is equal to 0.5. Alright, so now we got everything we need, so we can just plug it into here. Alright, so n, so 5 times the quantity of 2 times the first number, so 1, so it'd be just going to be 2 plus n minus 1, so 5 minus 1, which is 4, times the common difference of 0.5, all of that over 2. Alright, so now let's clean this up. 4 times 0.5 is the same thing as saying 4 divided by 2, so we get 2. 2 plus 2 is equal to 4, so we get 5 times 4 over 2. 5 times 4 is equal to 20, so then 20 divided by 2 is equal to 10. So we can rewrite this as a sub s, so the sum of a is equal to 10. Alright, so now let's get on to you guys' practice problems. Alright, here are you guys' practice problems I want you to try. You have 1 sigma notation, so that shouldn't be too bad. Alright, I'll have the answers in the description below. Thanks for watching. If you guys have any questions, put them in the comments below. Until next time, have a good day.